In this lesson, we'll continue looking at tables of value, two variable statistics. We're going to make a scatter plot. We'll look at the trend, we'll draw a line of best fit, and then we'll write the equation and use it to make a prediction. So this particular data table is about prom ticket sales. And apparently we're recording the number of tickets sold and the day that they started to sell the tickets. So on day 1, they sold 30. On day 2, they sold 35, etc., right? So the first part of this question says to create a scatter plot by plotting the ordered pairs from the table onto the graph. Okay, so let's look at how this scatter plot was designed. The independent variable here is time in days, and we're counting by ones. The dependent variable is number of prom tickets sold, and the fewest number that was sold was on day 1, it was 30. The most sold was on day 10, it was 70. And so what we've decided to do was to count by tens here, going from 0 all the way up to 120. And so on day 1, there were 30 sold. And there's my dot for 1, 30. Day 2, 35 were sold. Day 5, 55 were sold. I'm going right between 50 and 60 on day 5. Day 7, 60 were sold. Day 10, 70 were sold. So I've completed part A. Part B says to draw a line of best fit through the data points. All right, so remember, line of best fit, we want a straight line that, now, it's not about connecting the first dot and the last dot necessarily. It's more going through the data points in the general trend so that there's about the same number of points above and below. Maybe that's a little bit high, but I'll go with it. And it says to write an equation for the line of best fit. Now the equation is we're going to write in slope-intercept form. And remember, the slope is the rise over the run. And my slope here is positive. And I'm going to find a nice lattice point, this one right here. And I'm going to find another lattice point that the line goes through right here. I can look at my rise and I can look at my run. My rise, I'm going up by 30. My run, I went over 1, 2, 3, 4, 5, 6. So that's nice. 30 divided by 6 for a slope. That's a nice number of 5. So my equation is y equals 5x plus this y-intercept, which looks like it's about 22, maybe 24. So there's my equation for my line. And now I want to look at the question that asked me to predict the number of prom tickets sold on day 20. All right, so day 20, I can't really use the graph because it's off the graph, but what I can use is the equation. And that's what I'm going to do. I'm going to write the equation, and I'm going to write it as a function. F of x is equal to 5x plus 24. So I want to find f of 20, because that's the number of tickets that will be sold on day 20. Remember, this is a prediction. And order of operation says multiply before you add. That's 100 plus 24 is 124. So my prediction is on day 20, because the trend is increasing, 124 tickets will be sold. Now the reason why I could make that prediction is because when I drew my scatter plot, there was a clear trend of the data, and I used that trend to draw what's called a line of best fit. I found my slope and my y-intercept of my line of best fit, and then I used that information to find how many tickets will be sold on day 20.